Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All About Electricity, Part 7. Lithium Iron Phosphate Batteries, Part 1. This will be Part 1 of our discussion on lithium iron phosphate batteries, which can provide us with electrical power when the grid is down. We will start talking about using single lithium iron phosphate cells to build a battery bank. This will be one of our shorter sessions as we are getting into a more complicated topic, so I don't want to overwhelm you. In previous presentations, we have also referred to lithium iron phosphate batteries as LFP batteries. Well, another common reference is LFP, which are the letters for lithium iron phosphate from the periodic table. So in the future, the lithium iron phosphate batteries will be referred to as LFP batteries. We will be discussing the lithium iron phosphate battery bank for many more sessions, including battery bank configurations, battery management and maintenance, protection systems, charging your battery bank, and what to connect to your battery bank and how to use its power. We will be using terms like voltage, amps, watts, amp hours, etc. If you are not familiar with these terms, I would encourage you to view the video on voltage, amps, watts, wire size on our YouTube channel for a more in-depth discussion of these terms. It might help with what we discuss here. Additionally, I have created a video explaining the path I took in creating my LFP battery bank called My LFP Research, How I Got There. This video is also posted on our YouTube channel. Please watch it. Now down to the LFP batteries. There are two ways to build a LFP battery bank. We sort of discussed this in the battery bank basics topic a few weeks ago using pre-built 12-volt LFP batteries. We showed how to connect 12-volt batteries in parallel to increase the total capacity. Connect positive to positive and negative to negative in series to increase the voltage. Connect the positive of one battery to the negative of the next battery, and so on. And in parallel and series to increase capacity and voltage. Create each battery by connecting them in series to increase the voltage, and connect those batteries in parallel to increase their capacity. The other, DIY way, is to build your battery bank using individual LFP 3.2-volt cells. The pre-built 12-volt LFP batteries we talked about before are created using these same single cells, but you get much more control over your battery bank by building your own with single cells. When we talk about a DIY battery bank using these single cells, we will mainly refer to the voltage and capacity of a single cell. This is because, regardless of the total voltage of your battery bank, whether 12 volts, 24 volts, or 48 volts, the information provided for the single cells will be the same. This information will let you know the exact state of your battery bank beyond just using the total battery bank voltage. For a 12-volt LFP system, you will have 4 single cells in series, so just take the single cell voltage and times that by 4. For example, each cell is 3.2 volts, which is the nominal voltage of a LFP cell, then 4 times 3.2 volts equals 12.8 volts. For a 24-volt system, you will have 8 single cells in series, so just take the single cell voltage and times that by 8. That's 8 times 3.2 volts equals 25.2 volts. And for a 48-volt system, you will have 16 single cells in series, so just take the single cell voltage and times that by 16. That's 16 times 3.2 volts equals 51.2 volts for a 48-volt system. Okay, now we are all confused, so let's continue even deeper. Don't worry, hopefully once we delve into this, it will become clear or clearer why we examine each cell rather than the total battery bank. A piece of information here to keep you interested, so you will listen to the rest of this presentation. My LFP single cells are 280 amp hours each. 4 of them make a 12-volt battery. The cool thing is that this 280 amp hour LFP 12-volt battery is only 1 inch taller and 1.5 inches longer than a 100 amp hour deep cycle battery, and weighs half as much, yet has 5.6 times more usable capacity. You get a lot more bang for your buck with LFP batteries. I told you this was going to be a short presentation, and I kept my word. Next week, we'll continue our All About Electricity series and discuss more about the single LFP cells and how they make up your battery bank. We'll answer the questions: what a fully charged and discharged cell voltage is, and what causes damage to cells. How hard is it to determine your LFP battery bank's state of charge? What can happen when your cells are unbalanced? And why do you need to have the capacity of all cells the same? If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.